The data lifecycle. The data lifecycle starts the day that we first receive data. We must ensure that that data is adequately protected at all times and in all forms, all the way through the life cycle until the day that we then dispose of or delete that data. We have to plan for this. We have to identify what data we process and which of the data we process would be considered to be sensitive. In other words, sensitivity would relate to then confidentiality or integrity, as well as which data we process could be critical, high availability, and it's necessary for the business to have access to that data. So we start with identifying the type of data elements we have, determining the value of those data elements according to their sensitivity and criticality. And this is a process that we often call classifying the data. Now, obviously, when we classify data, we need an owner, someone who is then responsible for ensuring that that classification is correct, the data has been identified correctly. And what that will also do is the owner will specify then the handling requirements for that data. Then we design the data. We design the format, the structure, the size. For example, what type of date or time format are we going to use? Are we going to use a 24-hour clock, a 12-hour clock? What type of date format would we like to use? What type of character sets? Will we accept other characters such as, various accents and other types of umlauts and so on? The idea of designing then the format, structure, and usage of our data so data can be transported between systems, and of course this is really important when we're transmitting data between countries. Then we look at what is the process by which we acquire that data, or we build or create that data ourselves. Through all of this life cycle, we want to make sure that the data will be protected in accordance with, customer expectations. Our customers expect that if they trust us with their data, we will protect it properly. We'll protect it according to regulations, the laws and regulations, especially dealing with privacy, that come into place, as well as we'll protect it according to our business needs. If this is a trade secret or an especially important piece of information that we don't want a competitor to know about, then we need to protect it appropriately as well. We want to maintain what we call the state of the data. The state is just a term that refers to what condition is that data in at a point in time. And a good transaction or a good data flow through the organization should ensure that we maintain the correct state or the correct condition of that data at all points in time. Whether or not that data is electronic, paper, whether or not it's being stored, transmitted, or displayed. Then we move on to the usage and operation of the data, the storage, sharing, and processing of the data between different systems. And it's important that we then monitor to ensure that we maintain data integrity as well. Eventually, the data lifecycle will end at the point at which we dispose of, we archive or destroy the data. And this is actually something that has been a struggle for many companies. Let's say we have old equipment and we want to discard that old equipment. Well, the problem that can actually happen with that is that we may even have agreements in place for disposal of that equipment, but that equipment has had sensitive data on it. We need to audit and make sure that that equipment has been disposed of properly. We've had many organizations have found that the agreements they had for disposal of old equipment actually weren't being followed. We've had cases where companies had agreements for shredding companies to come and shred their data, and it wasn't being shredded. So we maintain the ownership of that data until that data is destroyed. And that's why it's so important for us as auditors to be checking that at each of these phases that truly this is working. We are maintaining the correct state of that data at all times and in all forms. Now, this also brings in the problem today of transporter data flow. What happens when I'm going to share my data across country boundaries? Different countries have different laws about the protection of data, and this is where we have to make sure that we are compliant, obviously, with those laws. The other area we have to be aware of is, of course, this area where we have now outsourced our data management to the cloud or to a third-party service provider. Even though that cloud provider actually has possession of my data, it's still my responsibility to make sure it's adequately protected. It's my data from my customers, and legally I have the responsibility to protect my customers' data. Even if I've given that data to somebody else to manage on my behalf, it's still, for the most part, my responsibility. And that cloud provider may have a very limited liability of what they are responsible for. Our databases, of course, contain the gold of the kingdom today, a tremendously efficient and effective method to store and access data. Vast amounts of data can be accessed now electronically, whereas in the past, if I wanted to store and manage data, we had dozens of filing cabinets with customer data in them. And you could only gain access to those through physical access to the filing cabinet. Today, we can access data from all over the world. We can store and access our data in a way through a database that prevents things like redundancies and duplication, prevents in many cases one person from making a change that the others don't know about. So the databases themselves, tremendous advantages here in how we can actually make our data more accessible as well. Some of the early databases were based on an hierarchical model. And an hierarchical model is where our data was all arranged in a tree with parent-child relationships. And in fact, in many ways, if you've used LDAP is a type of hierarchical model. Then you had networked databases, where you had these many-to-many relationships between different data elements. But today, we almost exclusively use what we'll call then relational databases. A relation is just a fancy word for a table, a matrix. The idea of a relational database is we store all of our data as records within a table. And each of those records has certain attributes or certain columns that describe that record. What is the customer's name? What is the customer's address? Each of those are attributes. And today, most of our databases are built on this type of relational database model. The relational database management system, then, is the librarian. It is what manages access to the data. Therefore, a relational database management system is really then managing the access to the data in my systems, so we maintain the integrity and availability of that data. As we know, a database, just like a filing cabinet, is a very good structured way to sort data. And this is done through the use of a primary key. A primary key is a unique value that identifies every record within a database. The primary key cannot be duplicated, and of course it cannot be left blank. When we create a database, we group things that belong together. And things that don't belong together, well, we keep in a separate area. For example, we have authors who write books. We'll usually then create two different databases. We'll have one database that lists all of the books, and one database that lists all of the authors. And each author would have an individual identifier. That would be their primary key. And of course, each book would have its own unique identifier, probably the ISBN number that's of course associated with each book. By associating all of the book data together through a process, let's group it according to what would be a normal process. The book table would have the book name, the book number, the price, the publisher. and would also then have the author number. That author number would allow us then to link to the author table. And in the author table, through a process of normalization, we'd keep everything that would be normally grouped together about the author in the author table. A database may contain a lot of data that not every customer should see. We could have a person, for example, who's doing work under a pseudonym. And we don't mind if a person looking up that author looks it up by the pseudonym, but we don't want then that person to know what their real name is. And that is where we'll put in place a view. A view is like a filter or a restriction we put on a database that limits what a person is able to view or what parts of the database they are allowed to see. When it comes to database security, we need to protect databases because they are, in many cases, the core gold treasure repository of the business today. This means we need to have good, solid backups, maybe being done continuously through disk mirroring, or maybe being done periodically through electronic vaulting. We have to maintain the integrity of our data, which means we have to protect the data from anyone putting in invalid data into the database. This, of course, if a person was able to put in invalid data, could damage the integrity and, of course, trust that I could have in my data. We'll quite often encrypt things like credit card numbers within the database, so they can't be, of course, captured by a thief. And it's very important we have sufficient layers of access control. And the purpose of the access control is to make sure that only authorized people have access to my data and that they can only do authorized functions when they have that access as well.